Hello everyone, welcome back to my YouTube channel. Today we will be understanding what artificial intelligence is really. Artificial intelligence is already part of our everyday life. It unlocks your phone, filters unwanted emails, recommends videos, understands voice commands. It can recognize objects inside images. But what is AI really? Is it thinking like a human, or is it something very different happening behind the screen? Let us begin with 5 simple examples that we use every day. First is face unlock. Your phone examines visual patterns of your face and checks whether they match the registered user. The second one is smart email filter. It examines incoming messages and separates normal emails from possible spams. Third, video recommendations. The system studies your viewing behavior and predicts which videos may interest you. Fourth comes the voice assistant. It converts your speech into text, identifies what you are asking, and performs an action. Fifth is image recognition. A camera or an application can identify objects such as plants, vehicles, animals, or everyday items. These systems may look very different, but they share one important idea. All of these use data to find patterns and make predictions. We need to understand how traditional programming and artificial intelligence are different than each other. To understand, we must first compare it with the traditional programming. On the left side, we have the traditional programming. On the right side, we have artificial intelligence. In traditional programming, a human programmer writes specific rules. The computer follows it for a given input, and then based on that, we get an output. But let's take an example. For example, programmer can write a rule saying if a number can be divided by 2 without a remainder, it is labeled as even number. The computer does not need to learn this rule. The programmer has already provided it. Now let's see the artificial intelligence. Instead of writing every possible combination of how a dog should be, we give computer data and examples. The AI model examines those examples, searches for repeated patterns. Based on the learned pattern, it identifies cat, car, flower, message, and a trend. The basic idea is simple. Data plus examples creates learned patterns. Traditional programming is useful to make clear rules. AI becomes useful when the rules are too complicated to write manually. Recognizing a cat in thousands of different photographs is a good example. A cat can appear in different colors, positions, background, and lighting conditions. Writing a separate rule for each and every possibility would be an extremely difficult task. Instead, an AI model learns from many other examples of cats and non-cats to identify cats out of all the images. Now we will understand the process of how AI learns. First comes training data, which contains the training data contains examples that the system can study. In supervised learning, these examples also include the correct answers. Step 2 is an AI model. The model processes the training data and begins adjusting its internal mathematical settings. Step 3 is prediction. The model receives an input and provides an answer. At the beginning, the answer may be inaccurate. Step 4 is error feedback. The model's prediction is compared with the actual answer, the correct answer. Step 5 is error feedback. Sorry, the step 4 was comparison. So step 5 is error feedback. The difference between prediction and the correct answer is measured. The error is used to update the model, which comes back here, and then this loop called as the feedback loop updates the model for the model to learn better and improve itself. Step 6 is repetition. The process happens again. For more examples, data enters the model, model makes prediction, prediction is checked, the error updates the model, and the process repeats many times. This repeated correction is what we usually mean when we say AI model is learning or training. It is not learning through emotions or personal experience as we do as humans. It is improving its mathematical ability to recognize patterns. We can understand this by a simple fruit analogy. Imagine a student who must separate apples, oranges, and bananas. At first, the student is shown several examples. These are apples, these are oranges, these are bananas. After seeing enough examples, student begins to notice patterns. A red shape could be apple, orange shape could be oranges, yellow ones should be put up in bananas basket. As I told, the patterns need not be as simple as the color, because the shape and all the other things as well come into the picture. Such as for bananas, they are usually long, yellow and curved. Apples are round, maybe green, maybe orange, maybe red. Orange are round and orangish in color. AI works in the similar way. It studies examples, identify patterns, then use those patterns to classify objects. A human student can use experience and common sense. AI model depends heavily on mathematical training and examples it receives during the training. If examples are incomplete, unusual, or misleading, the prediction can be wrong. Now, let's see the next example. Voice assistant. Let us examine what happens when you use a voice assistant. Suppose you say set an alarm. Set an alarm. The first stage is the voice. The phone records your sound as signals, speech as sound signals. Second stage is text. Speech recognition model converts the sound pattern into written words. The system now has a sentence. Set an alarm for 7 a.m. The third stage is meaning. The assistant identifies your intention. Your intention is to set alarm. It also extracts the important detail. Required time is 7 a.m. The fourth stage is action. The assistant sends the command to alarm application. The alarm is created. The phone then confirms that the task has been completed. The assistant is not understanding the request exactly as human would. It is recognizing sound patterns, language patterns, and possible intentions. Let's look at another example of spam filtering. Spam filtering is another useful example of AI. Several messages enter the email system. Some are normal messages. They may contain project updates or order receipts or flight confirmations. Other messages may look suspicious. They may promise a large price. They may demand immediate account verification. They may promise easy money. Email filter examines different signals. They can analyze the sender. It can examine the words in the message. It can check links, attachments. It can compare the email with previously identified spam. Now my messages are sent to the safe inbox, as it is shown in this image. Suspicious messages are moved to the spam folder. The system is making a prediction based on what it has been trained on or how it understands the images. The emails. The prediction is not always perfect. A genuine email may occasionally be placed in spam. A suspicious email may sometimes reach the inbox. This is why users can report mistakes and improve the system. Now let's see video recommendations. Consider a video recommendation system. The system learns your preferences and suggests video you are likely enjoying. It does not simply choose random videos. It studies several signals. The first signal is viewing history. It looks at the type of videos you watched in the past. Second is your watch time. Watching most of a video may say stronger interest than leaving after a few seconds. The third signal is skipped videos. If you repeatedly skip a certain kind of content, the system may recommend less of it. The fourth is similar users. Similar users means the system can compare a behavior to other people who have shown similar interest. All these signals enter the recommendation engine. The engine searches for patterns, then predicts which videos you are most likely to watch or enjoy. Based on that, the result may include science videos, travel destinations, quick recipes, or top gadgets. The system does not know you in the same way that a friend knows you. It makes prediction from your behavioral data based on your behavior. Recommendations can be useful, but they can also be repeatedly show similar material. This may limit the variety of information that reaches the viewer. Now let's understand the limitations of an artificial intelligence. AI can be useful, but it also has limitations. First one is biased data. If one group of training examples and another group has very few, as shown here, if one group has a lot of data but the other has very few, the model may have an unbalanced system. AI may perform better for one group but not for the other group. In this example, input is a cat but the model predicts it as a dog because we might have lot of dog examples in this data. High confidence does not guarantee a correct answer. Third limitation is poor lighting or unclear input. See in this one, the chair image could not be seen. Let me just cut that out. Chair image could not be seen. Darkness, blur, shadows, noise, or any other unusual camera angle can reduce accuracy for visual processing. The fourth limitation is lack of common sense. AI model may learn that bananas are usually yellow, but if it sees a red banana, it may get confused. It doesn't have common sense. A human may understand that the banana was painted, edited, or shown under unusual lighting. The AI model may only see something that it does not match its learned pattern. AI finds statistical relationships. It does not automatically understand the world the way humans do. There are certain misconceptions regarding artificial intelligence. Number one is AI is thinking like a human, which is wrong. It is just learning patterns. Most AI systems do not think, feel, or understand in a human way. They process data, recognize patterns, and they calculate likely outputs. Calling a system intelligent does not mean it has human awareness or common sense. So what is artificial intelligence really? Traditional programs follow rules written by humans, but AI learns patterns, data from examples. AI can make mistakes. It can reflect biased data. It can struggle with unclear situations. It does not naturally possess human common sense. AI is not magic. It is not automatically human like thinking. It is powerful pattern learning built with data, mathematics, and computing.